Okay. So, quiet, up here. All right. So the Bohr model. The Bohr model had in its center. What did it have in its center?
The nucleus.
Yeah, we had the nucleus, and the nucleus was made up of what?
Matter.
No. Protons and neutrons. Right? In the nucleus. And around the protons and the neutrons orbited what? Electrons. And the Bohr model was the first model to come up and say, hey, you know what? I think there are different orbits. And each of these orbits is a different amount of energy. Right? So Bohr hypothesized that the atom's actually made up of a nucleus. And inside that nucleus you had protons, neutrons. That was left over from the Rutherford model. And then the Bohr model went one step further and started giving electron orbits. It said, so this guy way down here, this represents the lowest amount of energy that an electron can have. To get up to here, this electron has to be given energy. Right? So you add UV light to it, or you add heat to it, and you heat it up, or you do something like that to give energy to these electrons. And the electrons will then graduate into these orbits. And for Rutherford, it was a yes or no, on or off kind of thing. In order for this electron to get up to here, he had enough energy, he had to have enough energy to jump to the next one. He couldn't just sort of hang out here in the middle. Right? And when an electron loses energy, it goes to the next lowest one, and then the next lowest one. Next lowest orbital. All right, now we've got, today we're going to take it one step further and we're going to talk about the quantum mechanical model. Quantum mechanical model. Everything is still the same as in the Bohr model, right? The quantum mechanical model still has the nucleus being made up of protons and neutrons. And we still have orbits. Occupy, I think that's occupy. Occupy orbits based on the amount of energy they have. Oh, but gone are the simplistic circle orbits. With a quantum mechanical model, you get things that look like this. You get orbits that look like this. And you've probably seen pictures of an atom that looks like this. Maybe not quite that good though. With the quantum mechanical model, you have 4 different types of orbits, only 3 of which we're going to worry about, right? You have something called the S orbit. And S orbits are spherical, round spheres. Round sphere. And it looks like a ball, you know. If I could make this kind of 3-dimensional, there you go, that's an S orbit. We're in the middle of an S orbit. All right, and while the Bohr model said that these electrons have to stay in this orbit, the quantum mechanical model,
So what is it? What are the last 2 words of the electrons?
round sphere.
No, the electrons.
They are the amount of energy they have.
I'm starting to think spell check is like your best friend.
Yeah, but it doesn't help me because I don't know if it's spelled right or not. It's like, it could be whatever. Yeah, that sounds good. And then we have something called a p orbital. And p two-dimensional. All right, it's not a flat, two-dimensional figure eight. It's like a cone sphere, like almost sort of like that, but more rounded.
Can you find anything else?
And then the d orbit. D orbits are crazy looking. There are two p orbits. So you got this with this, like that. So
You don't need those right now?
Alright, where are we starting?
you got like that.
We can't even see it, Dad. You guys need to push back. Yeah, where are we starting out?
For sure.
Now the fun part, the fun easy part comes in when when you try to figure out where these electrons in a given atom are, what orbit they're orbiting in. And that can all be done. Can I erase all this?
Yes.
I don't care. You can start running this down.
It's on your book.
Wait,
Your book actually, the Apologia of Chemistry, actually did a pretty good job of explaining this.
Wait, what's the fourth one that we won't talk about?
F.
Awesome.
And that's why we don't talk
I
about
was gonna say.
We know where this is going to go. So we actually work in those shapes.
And stacking orbital is the process of assigning an element's electrons to specific orbits. So in the process that we're going to talk about, if I give you, an example, if I give you boron, after we discuss this, you'll be able to tell me what electrons boron has and where they're at, right? How many are in the s orbital? How many are in the p orbital? How many are in the d orbital? And then we'll use that information to be able to predict the chemistry of these atoms. So
predicting the sun in seconds.
first, we need to talk about how we stack these orbitals. All right, so an s orbit can have 2 electrons in it. A p orbit,
Wait, can, meaning it always has at least 2 or...
once it has 2, it's filled, and you can't put any more in it.
The rest go to the next one.
P orbitals can have 6 electrons. And d orbits can have 10.
Where are the other ones?
What about F? Just out of curiosity.
What does F look like?
Can have 16.
What does
I
F
don't
look
know.
like?
I have no idea. F is crazy. F is like, it looks like a donut. It looks like almost like 2, mushroom cloud from a nuclear bomb. It looks like 2 mushroom clouds on top of one another. So you got this this mushroom followed by another mushroom. Crazy.
I like it too. It's my favorite. That would be a great conversation starter.
All right. So let's talk about an atom. Let's look at hydrogen. Can I erase this?
Yes.
Hydrogen. How many electrons does hydrogen have?
1. No. 1, yeah, 1.
1 electron.
hey, can you put this periodic table thingy here? It's way too far now.
You're supposed to memorize this.
Yeah. Yeah, I guess I could do that. I'll do that for next time then. All right, so hydrogen.
Just put 1 like
hydrogen has 1 electron.
Okay, so
What would be I think it's actually easier if I just give you. Nah, let's just do it this way. Okay, so hydrogen has 1 electron. And so it has 1 electron in its orbital. Its electron configuration, its orbital is going to look like, it's going to be 1s1. Right? It has the 1s orbital with 1 electron in it. I can have multiple s orbitals, and we will be looking at that shortly.
wait, can you have like? Oh, okay, wait, right.
How about helium? How many electrons does helium have? Helium has 2 electrons, right?
Yeah.
Right, so how many electrons can an s orbital have? 2. So we're going to go 1s2. Alright. Easy peasy?
So far.
So far.
But I have a feeling you're going to do something that's going to be really complicated.
So far? No. It's not going to get too much complicated.
Like,
Okay, lithium.
just a little bit.
Lithium. How many electrons does lithium have?
3.
3 electrons. Right? So lithium's going to have 1s2 and then 2s1.
Wait, would you put 2s because it's the second one?
Second s orbital. Basically, we're just going to keep stacking these into these orbitals until we use up all the electrons. Okay, now there's a pattern, and the pattern looks like this. 1s2, 2s2, 2p6,
By the way, I cannot see
3
that because of the lamp.
s2. Bummer, really?
Just gonna lift it up.
Yeah.
I like
3p6, 4s2, 3d10, 4p6, 5s2, 4d10,
You know, chemistry always starts off really simple.
5p6.
And then that actually say pretty simple.
What if, yeah,
What?
but one of the numbers restart before each one, since it's like, when it's 2p, wouldn't that be 1p because it's the first p?
Can't like.
Good. Okay, so what we have, if you look at, this is the pattern that we're going to be using. If you notice, there is no 1p level, no 1p, right? And there's also the d's are always behind by 1.
Why?
Because there's not.
Because if you look at the periodic table gives you a clue as to how these things are filled in.
Cannot see.
Well, you will once I draw it.
Probably not.
Your drawing is as good as your handwriting.
Thank you, I appreciate that.
Here you gotta say that. I don't think Mr. Biden is an artist.
All right, here's helium,
Actually, it's pretty good at all.
here's hydrogen,
I think they're all the same.
here's these guys. All right, so what we have, these down here are my s orbitals. These are my p orbitals.
Wait, how do you define whether the S or P?
These are the d orbitals.
Because somebody's like, oh, I'm just gonna say it's gonna be weird.
All right. I think I'm making this too complicated.
Yep.
Yeah.
Nope.
Way too
Wait,
complicated.
okay, if you can explain to me why
Okay,
this has to.
let's take a look. So hydrogen here is, what did we say, it was 1s1?
Yes. Yeah.
1s1. Helium, which is in the same level as hydrogen, is 1s2. Right?
But it's in the P column.
Look up here, look up here.
It's in the P side though.
Okay, wait a point. These right here are the P's. Actually, these are. Helium is one of these guys that are sort of off by itself. If you notice, it's not real well. but it's considered an s orbital. All right, so we're going to come back over here for lithium and beryllium. We're back into, here's 1s. We come back over here, these become 2, right? So we got 2s, 1, 2s2. These are actually up a little bit. Right, so directly across from this, we have our p orbitals. So right here is boron. Boron is going to have a p orbital, and it's going to be 2, right? We're in row 2, 2p1. You know, it's like one of these things that it's sort of, when you first look at it, it's complicated, but then it's just like, oh wait, this is really simple. All I've got to do this. So let's take a look at something.
Like multiple ratios.
Thank you. Let's take a look at carbon. Carbon has 6, right? So carbon has 6. It's going to have 1s1, 1s2, right? Going to have 2s2 filled in. And when we come over here for p, it's going to have 1 p orbital filled in, 2 p orbitals filled in.
The light bulb still is off.
Yeah,
It's flickering.
It's flickering.
My bulb is out.
Okay, so here we got carbon, right? Carbon is going to be 2p2. What's the next one? Next one is nitrogen. Nitrogen is going to be what? 2p3. Next one after that is oxygen, 2p4. Next one after that, fluorine, 2p5. Next one after that
6.
is neon.
You got something right there, right?
Neon, 2p6.
Really quick here.
You see that?
Okay, now show them.
Yeah, okay. Okay. So here comes the curveball. We're wrapping around here,
Stop.
and we're going to look at sodium.
You need to draw a line under the AG. Under the helium. Yes, thank you.
Really, Grace? Seriously?
Okay, so now we're wrapping back with sodium. Sodium is in the 3rd row.
What do we got?
It's in the S column.
S3S1.
3s1.
3s2.
What's the next one? Manganese. What is that, Grace?
3s2.
3s2. Look at how easy this is. Next one, we're coming over here. We've got aluminum. Aluminium.
4.
It's P.
3.
PS4.
PS.
P. So this is going to be
PS4.
3p1.
Oh.
Right, we're in the 3rd column. 3p1. What's the next one?
3p2.
Silicone. 3p2. Next one.
Potassium.
Potassium.
3p3.
Phosphorus, sorry. Phosphorus. 3p3. Oh my gosh, this is easy.
So
You see it? Okay.
She's blind. That's why
what's
she's so
wrong?
Okay, but now, when someone asks you to give me the electron configuration of, let's say, phosphorus, you have to give them the whole thing. Oh my gosh. So it's 1s2, 2s2, 2p6,
What?
3s2,
Yep, the light bulb just died.
3p.
You shut up! Oh!
Okay, look at this though. How many electrons does phosphorus have? Phosphorus has 15 electrons. You have to account for every single one of those electrons. What orbit are they in? Well, the first 2 electrons for phosphorus are in the 1s orbital. The next 2 electrons for phosphorus are in the 2s orbital. The next 6 are in the 2p. The next 2 are in the 3s. And then the last 3 are in the 3p orbital, giving you a total electrons of hopefully 15. Do 10,
Hey.
12, 15, 15 electrons. You have to account for all of the electrons, and all you got to do is remember this and fill them in until you run out of electrons. Oh my God. That's a lot of fun.
Only in
We all define fun in different ways.
This is like no-brainer stuff. Once you figure out how to do this, I mean, really, give me 100 of these and make it a test. I'll get a 100.
Yes. One concept. Please. Yeah, I can only do it.
Mr. Mike,
Yep.
so if phosphorus is just an element,
Yep.
why would you list all of it? Like what you just listed elements? Or whatever.
This is just the electron configuration of phosphorus.
Or-
I'm totally ignoring neutrons and protons because they don't count.
Okay.
Neutrons and protons don't amount diddly in chemistry. It's all about these electrons. These electrons is what make chemistry happen.
Okay, but how do you find that? Like you just.
The electrons?
Yeah.
You can do it one or two ways. You can use the periodic table and know that all these have to be S's, all these are P's, and these are D's, and just go right along.
Yeah, you can't put anything else on there.
And go right along, filling them in, or you can memorize this.
Holy.
I'm gonna use the
I
periodic
can't
table.
see it. How can I remember?
Here, let me go ahead and give it to you.
That's great.
1s2, 2s2, 2p6, 3p5, 2, 3s2.
But really, I would rather you understand it than just memorize.
What's written up there?
All right,
So
so,
we like mark that on our periodic table.
well, it's already marked, right? Here's the S, right? Okay, you got to remember the helium is actually over here. So here's the S's, here's the 1s, here's the 2s, 3s, 4s, 5s, 6s.
Yeah, I got that. I'm talking about just like the order of that.
Okay, so you've got the 1s,
Oh, I see.
then there's nothing else here, right? So after the 1s come the 2s. Oh, we got P's now, right? So there's your P's. We come right back around with the 3s's. Nothing else. Oh, we got 3 P's, right? So you got these P's. Run out of P's, then you come back, wrap around to 4s's. Now, the tricky part is these D's are going to throw you off. This is the D right here. The D's run one number behind your current level. So while these D's are with the 4s's, these are 3 D's. 3 D's, back to 4 P's, 5s, 4 D's, 5 P's.
Because they're higher, they require more energy.
These have a ton of energy. It takes a lot of energy to get to the orbit.
But I'm still confused as to how you get like the superscript, like the 2, 2, 6.
Okay.
Where's that from?
You can only, the s orbitals can only have 2 electrons. The p orbitals can only have 6 electrons. The d orbitals can have 10.
Okay.
All right. So if I'm out here, I know that if I come up with a p7, something's wrong. I can only have 6. 1, 2, 3, 4, 5, 6.
Okay.
And then it's filled, and then you got to go to the s orbital.
So you can do that.
Do what?
So all of the S's are going to be 2s, and all the P's are going to be 6s.
Absolutely. All the d's are going to be 10s.
Okay.
All right. Should we do one?
No.
Yeah. Let's do one.
He's still on.
Who wants to do one?
Me, pick me. Einstein's. Me.
All right, Grace.
Right.
Come up here.
Hey,
Let's
I
give
volunteered
Grace-
last week.
We will give Grace
volunteer last week.
chlorine. Give me the electron configuration of chlorine.
How do I do that?
Okay, we're going to start at the very beginning,
Actually, not started.
and we're just going to start filling in these orbitals until we get to chlorine. And so we got, the first one is our s orbital, 1s. Those are both going to be filled. All right, so it's going to be 1s.
3.
Yeah. 2.
Oh,
So all right, 1s2.
Where?
All right, here. All right, 1s2. All right, so that took care of my 1s. There's nothing out over here now, so I got to drop back down here.
Wait, how
Here
is it
again.
1s2? There's 2 and
No,
You gotta be kidding.
there's a maximum of 2 electrons
So,
in an s orbital.
2s2? It's 2s2 because it's passing over 2 of the s slot.
2s.
You need to
2s.
understand a little bit about.
1, 2, just 2.
2s2.
Right, we're trying to get up to here, so we got 1s, 1s2, 2s2,
It's not a P, so it adds.
Right, I got
P,
So Alex,
So that's why it's 2.
2p,
for that particular one, you
One.
can you can
Nope.
1s2
Two.
just pass
1,
over
2,
1s2.
3, 4, 5, 6,
2s2 just pass over
6.
2s2.
2p6,
You
and
can
then
6.
we're back down here
Pass over 6 2p's.
at our, how many s's now? 1, 2, 3 s's?
3s.
3s,
2.
2. She just said that. 2. No, why is it 2 and not 1? Because we're not to chlorine yet. These are filled in. We got to get all the way up to chlorine. So as long as we're not at chlorine, we're filling in all these orbitals. Each one of these slots just represents an orbit. Don't look at it as magnesium or sodium,
Look at this as an S. It's an S.
right? It's an S. These are P's. So both S's are filled here, right? Both of these are filled because we're not at chlorine. We got to get all the way down here it's a path. You got to follow the path until you get to chlorine, right? So both S's are filled. Both of my 2 S's are filled. All of my 2 P's are filled. All of my 3 S's are filled. But now I'm at chlorine. I'm at my 3P, but my 3P isn't all the way filled because now I'm at chlorine and there's still 1 spot left. So this is going to be 3P, 1, 2, 3, 4, 5.
5.
Now we gotta write it all down. Oh my God. Alright, so this is our pattern here. So we got 1s2, 2s2.
Yeah.
Alright.
3s2.
Nope. Is it-
What?
Yeah, look. Here you filled in these two. You've got an electron here, an electron here. What are these? You're over here now. These are
Protons. Neutrons. Electrons.
p orbitals.
P orbitals.
We're not, ignore protons and neutrons. Protons and neutrons have nothing to do with what we're doing. Alright? We're at orbitals, right? We're filling in orbitals, so we got 1, 2, 3, 4, 5, 6, 2p's, 2p6. All of these are filled in because we're not pouring yet.
So they're all 2p because you went down 1 row and they're still p.
This first row is 1. but
This
it's
is
only
2p, this is 3p, this is 4p, this is 5p.
Wait, does it keep going from there?
Yep. 6p,
Okay.
7p, and then you're out of elements.
Okay.
Can I do it?
Yeah. Well, hold on. Let's torture her some more. So we got. You're at 2s. How many p's do you need? This is what. First of all, what number p is this?
2p.
2p. Excellent. 2p. How many electrons are going to go there?
6.
2p6. Right there. So all those are filled in. Now we're back to the 3s orbits. How many of these are going to be filled in?
2.
2. 3s, 2. Good. Write down. Now we're over here to what? P.
3.
3p. How many 3p's are going to be filled in?
5.
5. 3p5. And that's the electron configuration for. Well, you got to write it next to it. That's the electron configuration, the total electron configuration for chlorine.
Why do you have to go through them all like that?
It's just torture.
that.
No, we will talk about why this is important because the valence electrons, which is what we're trying to figure out here, the valence electrons make chemistry happen. Valence electrons are these electrons out here that are all by themselves. When their orbit isn't totally filled in, that's going to be valence electrons. And those electrons are out there just waiting to cause trouble. Alright, and that's what chemistry is all about. That's what causes chemistry to happen. It's these guys that aren't full looking to steal other people's electrons.
I like it.
Alright, give me the electron configuration for calcium.
Alan, did you write like middle to low on the board?
So now other words, you should
Like right
write
here?
really high.
This guy?
Yeah, that's good.
It's like coffee.
It is.
But,
I haven't had coffee.
So should
And
we
it could-
write this in on our books?
You can.
And then it would save all that trouble every time?
Well, I want you to understand that, you can write that 1s2 and 2p3 right across here.
Why?
And that would be,
I don't
you
get
could
that.
memorize it, you would never have to worry about it again, or you could understand that
actually, no, it's
1s, 2s,
Mr. May, what
3s,
do
4s.
No, incorrect.
Stop standing for?
Those are the orbitals. The s orbital, the p orbital, and the d orbital.
Actually, yes.
Wow, that's quick. Is she right? Let's see. Calcium, we're trying to get to here. So we got 1s2 is filled, 2s2 is filled, 2p6s are filled, 3s2 is filled, 3p6 filled, good. 4s2, good. Everyone see that? But don't erase it. Oh, nice.
Great, now I can't see it. Or just like email.
So would H be 1s2?
H, helium?
Yeah.
Oh, wait, that's hydrogen?
Yeah.
Yeah, hydrogen or helium.
So on the test,
Hydrogen.
can you
One of them you're right, one of them you're wrong.
Hydrogen.
Hydrogen would be 1s. How many electrons does it have?
One.
1s1.
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 So on the test,
1s2 would be what? What element?
helium.
Helium.
So on the test, can you put like hydrogen, helium, lithium, and beryllium?
Oh, no, we need down here into mendelevium and
No.
nobelium.
Two hours later.
Okay, but look how easy this is. If I wanted to say, hey, come and do scandium. Alexander, get up here and do scandium. Look how easy it is to do scandium. Jump up here.
Oh, you
Leave yours there. Leave yours there. And now do scandium. Here's scandium.
Okay.
See, this is no. This is I'm trying to show you just how easy it is. Okay, so look, she's already done calcium. Look. There's calcium. You gotta do cells. You gotta do stick that d orbital on this 3d1 and you're done. You're here.
I'm going here. Okay, so
D orbitals run one number behind your s orbitals. So this is going to be a 3. 3 D 1. And you just turned calcium into scandium. Everyone see that? Oh man, that was sweet.
What happened?
another stuff.
He